Okay, so hello everyone. Um, I'm going to begin by helping you guys a little bit with your program for your final/project. Now, this program here called Bouncing Ball is actually in the book. This one I call it Bouncing Ball Original because this is the original, and I do have a modified Bouncing Ball. So this is all the code there is in that program. It has some variables here. Mainly they are final, so they don't change. This is good, such as the size of the ball will never change. So if they're going to be constant, make sure you put final. It does not have a main though. So an applet does not have a main. It has different sections to it that are different, such as the init, which is initializing your program. It's got the paint section, which does all the drawing, and the action listener, which does any other types of calculations. So depending on what the action listener is modifying, the way it's going to paint it is going to change. So as you can see, Y is going to be changing here, and I'm using Y to help me with the fill oval. So let's see how this program looks right now. Okay, so you can't really see anything, but notice as I move the window, you can see the bouncing ball up and down. Now the reason why you can't really see it if it's stationary is because it's single buffered. We need to change this to double buffering in order to take full advantage of the display. So the computer is too fast, it's just not able to display it long enough for us to see it. So I sent an email to everyone, and it has an email, this one up here. This is not my site, this is just a site that I always take my students to because it has a very easy way to understand how to change your program into double buffering. It's got comments, so many comments. This program has something to do with the mouse, so we'll see that later on when we're doing the little paddle in the bottom. But for now, let's just change it to double buffering. So I'm going to go ahead and put these two programs side by side, and let's see some of the things that we may need to change. First off, this has this included at the top. Okay, and it has extends applet. We could leave ours as JApplet, it's perfectly fine. This one's using a mouse listener. Our program is not using a mouse listener, so that's something different between them. They do include a few extras here, which is the graphics. Image. The dimensions of the screen, and the current X, current Y is something they use for their mouse. So these are just three little things. The thing that changes the most is going to be the paint. But for now, let's go ahead and set up the initial first. So the initial for our ball is just calculating the timer of the ball. So it's just going to be going at a certain speed. So the time delay says what speed we want it to go to. Well, first off, I'm going to say the same stuff that they have. The dimensions of the screen equals, it's going to get the size of the screen, not the screen, sorry, the window. I do not want to add a mouse listener. I do not want to change the background. The off-screen equals okay, so what this is doing basically is it's going to set a off-screen window of this size. Now, personally, I do not like to use this unless I know the exact size of the window. So I'm going to go ahead and set up a size for the window by default. Okay, so I'm going to set the size as 500 by 500. So now when it gets size, dim has the width and the height. So it's got the 500 and 500. A smarter way to do this would be to create variables for this. Okay, because later on we will want to know the size of the window, because the ball is going to be going all over and we want to know the boundaries. So far off screen, now we need okay, so now buffer graphics equals the off-screen get graphics. So this is just setting up our program. It's setting up the buffer graphics, the off-screen, the dimension. It's getting all the variables it needs. But the true magic happens in here. So in the current paint, it is just setting up the panel that you're seeing and drawing it onto it directly. What we want it to do is something over here. So what it's doing is first setting everything up in buffer graphics, and then it's going to draw it onto the screen. So at the very end, it's going to draw whatever's in the off screen onto the screen. Let's see how that looks when we type this in. Okay, where am I? So first off, I am going to use the size of the screen for a few things whenever I paint. So I'm just going to go ahead and do it once again. Just so that I know. Now, the reason I do this mainly is because if it opens up a window and you resize it, well, the dimensions have changed. So I make sure inside the paint that I have the dimensions. Okay, so we have this, which is no longer in here. I'm going to remove this. And this is just setting up the colors. Instead of changing the color to G, we're going to change it to buffer graphics. I don't know why these two are indented. Let's move to the left. Okay, so now the buffer graphics has this. The buffer graphics will now have the fill oval. And that's all it's doing. It's just everything is going through the buffer graphics. And then finally at the end of it, it's going to go ahead and G dot draw the image of the off screen. 0, 0 is, it was already there, but it likes to add extras. This is good. Is that it? Let's see. We're missing this little thing here. Now it explains to you that it's always required for you to do good double buffering. So let's do good double buffering. Okay. Everything else is based on the mouse. Let's see if this alone is able to change our program. Whoa. Close. There's only one thing that's needed. Now, when it's drawing it, it's not really clearing everything on the outside, and that's because I missed the first line here. So the reason why we have the clear rectangle is because we want to clear everything on the screen. It's kind of like in C++, it's the clear screen. So let's go ahead and go back to the paint, and I'm going to clear it after I get the dimensions so that I could do the rectangle starting from 0, 0, which is the top left corner, all the way to should be the height. I don't know why they have dimension width, dimension width. So if yours was different, then they have a typo. Okay, so window width, window height. Let's see what the program looks like. Hey, you could see the ball perfectly. Now, it does go all the way to just this spot because of the way the action listener is going. So the action listener, it's going to start off by, if it's going up, which right now is true, going up is true. If y is greater than the minimum y, it's going to basically move it 1 in the negative direction, which, by the way, negative direction is up. So upwards, up here is 0. The further down it goes, the bigger the numbers. So if y is bigger than the minimum, that means it's not at the top. So keep moving it up. If it already passes the minimum, then going up equals false. So now if it's false, it's going to keep doing this one. If it hasn't reached the very bottom part, then it keeps moving downward. Okay, so as y increases, it's going down. If not, okay, so if it already passed the maximum, you start going back up. So this is just going up and down, up and down. That's it. It's not really too difficult of a program to see, all the details that they're using and to implement something with it. I'm going to go ahead and add a little more to this. By the way, the repaint, you need, anytime that you make a change and you want it to be viewed in the screen, you have to repaint it. We'll see that whenever we use the mouse as well. Okay, so far we just have this little thing, and if I want it to be moving all the way to the top and all the way to the bottom, it would be nice if on top of here I set it to where the max y equals the size of the screen, right? So the size of the screen is 500. Therefore, I'm going to put 500. Now, the bad thing is, it's based on these constants. If I were to change this to 600, then it changes my program as well. For now, I'm just going to leave them as 500. And another little tricky thing is that if you have it as 500 and you run it, notice how it went past this line. And that's because when it's calculating the ball, it calculates drawing it from the top left. So when the top left hits the bottom limit, well, the ball fully went all the way outside of the square. So it's not actually going up to here, it's going up to there, minus the height in capital letters. Okay, now the ball is going to go up to where it should. Let's make the ball move left and right. So I'm going to go ahead and do going, if it's up, then it will be left. So going left equals to true. How exactly this is going to change the program? Well, first off, the y was always changing. This is the y-axis. Let's go ahead and change this one to a lowercase to say, hey, you're also changing. Let's see, they have a minimum Y and a maximum Y. Let's put a minimum X equals to 0. The max X equals to okay. And I do believe that should be enough for us to determine the ball going all directions. Go ahead and move it there. The code is very similar, so I'm going to go ahead and just copy it, paste it right underneath it, and instead of if going up, it's if going left. It's not calculating the Y, it's calculating the lowercase x, and going left equals false. Else, it's the same thing, you're just going to change these values to x, and going left equals to true. Did this draw our ball moving correctly? Oh, there's an error. I already know there's one thing that's missing. Oh, look at that. I changed this to lowercase. There we go. Wow, that is moving left and right and down and up and bouncing all over the place. I don't think it should cross. Nope, it doesn't cross on either side. So now we have a ball that's able to move left, right. It's able to move all over the place. Okay, this is what we have so far. This up here is what we're gonna try to get. As you can see, it's moving on my paddle, and it's kind of game over. So let's see how we can do this. By the way, I have it to where it could detect the paddle and bounce off of it. I do not have it to where it gets the blocks. I'm leaving that all up to you guys. If you go the brick breaker route. Okay, so going back here, there has to be a paddle. So I'm going to have to paint a paddle. I'm going to go ahead and paint the paddle before the oval. Dot. Well, how am I going to... Let's get a dot. This is fill oval. In a little bit before this, it starts covering how to do rectangles, how to do all those type of things. Right now we're going to do a filled rectangle. So I'm going to dot again. It's got 4 different coordinates. Just like the fill oval, it needs to know where the starting location is, which is the first 2 x's, and the size of it. So I want the paddle to be a specific size. Let's make the paddle width 100 and the paddle height 10. I don't want it that thick. Next, where's it going to start? I don't know. Let's put constants here, and we're going to change this, by the way, later on. I have no idea where that is located. Let's find out. Oh, our paddle's up there. It's not moving with our mouse. Instead of being up there, how about we make it start at a constant location, which in this case, the constant location would be whatever the window height is minus, let's say, 80. So remember, the window height, 0 is at the top, and it goes down, so when you subtract 80, it moves it a little bit higher. There it is. Now this here is supposed to stay there. It's not supposed to follow your mouse up or down, but it is supposed to follow your mouse left and right. So for that, we're going to use a bit of stuff that's in here. These guys. Actually, I think I could copy it straight from copy. Let's go after this. Be aware, do not copy it inside here because you'd be inside the action listener, and that's bad. Okay, current X, current Y. Those are variables that they declared here. So I'm going to go ahead and do that as well. Current X, current Y, and another thing to implement is the action listener. The mouse listener, sorry. And I don't like it being at the end, I like it being at the front. That's just personal preference, it doesn't really matter. And I don't know if there's a mistake somewhere here, but we are not going to have to calculate the Y. The Y is going up and down. We only have to calculate one thing, which is the X. So let's get rid of this. The current X. Okay, so we're going to use this math when we're drawing this here. I do not know if you want it to be like that. I personally would choose something different, but let's go ahead and run it and see what it does. It is not moving. Why is that? Okay, so it's currently constant inside cur X, which is at 0 in the beginning of the program. Now, the reason it's not picking it up is because, well, we do have these listeners, but we never implemented them. Which is, there's going to be a line here that implements, it's this one. We never actually wrote this. I skipped it in the beginning. There's got to be a way for it to pick up the signal, which is right here. I'm going to go ahead and paste it in space, and let's see if it could pick up. Look at that. Of course it goes through, but hey, this thing is following the mouse. Wherever the mouse X is, that's where it goes. Now, I don't like how it's at the far left, so I want it to be at the middle of the panel. Let's go ahead and change something there. Oh, sorry, it's right here. Let's start it at current X, and we are going to subtract 50. Now, the reason why I have 50 is because the paddle width is 100. So if I move the location of the current X 50, it should be able to move us to the center of the paddle. There you go. The only bad thing now is if I accidentally move out of the window, it's not moving, and I've lost so many times in the game that I made like this. There's some workarounds, but right now I'm just covering the basics. Now it's not actually hitting anything, it's not hitting the block. We'll worry about hitting to the end. Let's go ahead and draw our squares in the top. That's going to be the fun part. Now, I personally prefer to keep everything as an array. So the squares at the top, I want to draw them as, let's say, 5 by 5. So 5 by 5 is an array. And in order for you to determine whether a square is active, it has to be in the array as still present. So if, let's say you have an array of 5 by 5, and every element in there is a 1. That means all the blocks are present. Now, if block 0, 0 is a 0, that means the top left square, which I'll demonstrate up here, and hopefully I don't lose. This top square is not present. So this one is 0, 0, 0, 1, 0, 2, and so forth. It keeps going. I guess I can lose. There you go. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and then it goes to 1, 0, and so forth. So if you keep these as an array, and all of a sudden the block, this one here, gets hit, it's supposed to be gone. And if it's a 0, you don't draw it. You do the same thing with all of them. If there is 0, it's been broken, and your ball should be able to pass through it. So all of those are through conditions. We'll get a little bit into it once I get the paddle. But I'm going to go ahead and create a... Okay, right here I am going to do... two-dimensional array. In the init, I am going to... anywhere really. I'll just do it right here after this. Okay, inside the init, I created an instance of the bricks. That's it, that's all I did. Instead of creating it up here, I just said whenever I initialize, so when I first start the program, it'll create an instance of my 5x5. There's nothing in them yet. Okay, we'll do something with it later on, such as, well, let's say I create, actually I'm going to go ahead and initialize everything. Okay, inside here I'm going to make bricks of x, y equals to 1. That means all the bricks are active. They're all there. Inside the paint, we're going to go ahead and start drawing them. So, let's see. Go ahead and do it after this. No, after you clear the screen, obviously, or else I'm going to erase everything that I've done. So, same thing as before. Okay, we have our double array. I'm going to go ahead and put inside here this line of code. And I want to make sure that the bricks are, let's say, blue. So this is going to color the bricks, and after it's finished coloring the bricks, it's going to change the color to red, and then draw the paddle and the ball. Okay, so let's try the blue. And if the bricks of xy is equal to 1, then I'm going to draw it. If not, then I'm not going to draw it. Okay. So the else is basically skipping it. If I don't draw it, it's skipping to the next one. So that's perfectly fine. Now, unfortunately, this involves a lot of mathematics. I went ahead and came up with the formula for it, but if you want to draw them all in the manner that I'm doing it, it does take a little bit of, studying it, making sure you understand it. I'll go ahead and try to explain as best as I can. Okay, so did it work? But Here you go. I don't know why I didn't do it before. Okay, so in the first one it says, where do you want to start? Now your first one should be 0, 0. And as y increases, it should move on to the next square. When x increases, it should move to the square underneath, and so forth. So the y is controlling across, and the x is going up and down. So the way this one is a little bit different from the actual coordinate plane. I'll go ahead and write the first one here. The first one is, well, it's going to start off with 0, plus I am going to add a square. Now what's the size of the square? Well, the size of the square is the window width divided by 5. Window width divided by 5. That means you're making 5 squares. You're dividing the entire line up there into 5. And I'm going to multiply that by y. Now, the reason why I'm multiplying it by y is because there are multiple squares on there, left and right, up and down. I want this to change, so the very first time it's going to be at 0, and then the next time it's going to change into 1/5 of the size of the window times whichever element I'm currently on. So it's saying if y is 1, we're talking about the second square. If it's 2, it's talking about the third, and so forth, because the first square is at 0. Same thing with this one here. It's going to be 0 plus, this one's trickier, window height divided by 3 divided by 5 times x. What? Yes, exactly. First off, I did window height divided by 3 because when I run the program, look at the original up here. I'll go ahead and lose. If I do it divided by 2, then it's this entire size divided by 2 is up to here, which means the 5 squares are going to go up to here, which gives you very little space. So I wanted it to be 1/3. So if I divide by 3, it's going to go up to here. This is 1/3. If you want it further up, you divide it by, I don't know, 1/5 maybe, and that'll really knock it higher, so the squares are going to be a lot smaller. And then once I divided it by 3, so I'm only working with this top section, I also broke it up into 5. So that's why it's divided by 3, divided by 5. The times x is saying which square I'm talking about. Okay, so we did that math. That's pretty good. Next, this here is talking about the size. Well, what's the size? I'm going to get the window width divided by 5 because I want there to be 5 squares. So however big the window is, generate 5 squares. So they're all going to be 1/5 the size of the window width. But I'm also going to take off just a little bit. So 2 is very little. If you want there to be more of a gap, you could put 3, 4, less of a gap, 1. If it's at 0, so if there is no gap, you're just basically creating a solid square at the top. So you need to differentiate it with this little gap. And the last one would be window height divided by 3 divided by 5 minus 2. So now it's doing order of operations, it's doing all of this first, and then at the end, subtract 2. If you don't feel comfortable with that, you could also put parentheses on different sections. Let's go ahead and see how our original looks like. Yeah. So there's our original, we created this here. Now what would happen if all of a sudden I said something like breaks of 3, 2 equals 0. Oh, this is 3, 2. See, so as you start breaking a square, you change the value in the array from a 1 to a 0, and it'll no longer draw it. It won't draw it because it'll only draw anything that's a 1. Now, something cool you could do with this is something like this, to where x, if it equals a 2, I am going to change it yellow. No. Let's see. Hold on. So it is supposed to be drawing. Okay, well, we'll go ahead and see what this does. Obviously, we didn't put any yellows. Let's change that. I am going to put a now you're going to see how this is slightly off. File. What happened? I just put one square, yet it just kept on. Right? The reason why is because inside the y, it's going to do all 5. If I had changed this one to, let's go ahead and change this to a 1, or a 0 actually. If 0, 0 is that, it gets the whole line. So in here we have to differentiate between it being a yellow and it being a natural blue. So if you'd like, you can always put this in here. So if it equals to a 2, you can do it's supposed to be this as well. I don't want to have to copy paste this, but let's go ahead and do that. Sorry if you can't tell what I'm doing with this shorter screen, but I'm just making the if statement have both and both. Let's see how this looks. See, so now 0, 0 is yellow. This one here is, well, it was never drawn, and everything else is blue. So you can do it to where it starts off with everything blue, and it hits, and it turns yellow, and then it hits one more time, and it turns red or pink, and then the next time it just vanishes. So this is the vanishes, this is after it got hit once. So far we don't have any collisions. Let's go ahead and add the collision to the paddle. Okay, to get a collision for the paddle, we're going to have to make sure that we say if it intersects. Something like, I'll go ahead and do the, I'll have to do this here, which you'll see in my Flappy Bird program. Rectangle. The ball is and the ball location is, well, we already know from last time. The ball is W. The ball H. Sorry, that was what I was using last time. It should be just width and height. That's the same line as that. Okay, so that's getting us our ball. I'm using only 3 letters. We also need to consider another rectangle called a paddle. And this paddle equals and the rectangle for it, it's got a whole bunch of different things. I'll go ahead and I'll put this here. This is our paddle. Right? Now, if the ball intersects the paddle, going up equals true. That's all that's happening. You hit the paddle, go up is true. Saw that? Paddle is working. Okay. So obviously it's going to go through it if it hits it from the bottom because it's already going up, but we got this working at least. It's a similar topic to up here. The only problem with breaking it up here is if the ball is going one way, will it continue going? If it hits it from the sides, you don't want it to go through all of them. So you have to know whether it's hitting it left, right, top, or down, and so forth. So some more mathematics down here. I believe that's almost everything except for the way I ended the other program. So the other program, I ended it down here when it's moving here instead of going back up. So this else says if it hits the bottom limit. So if it hasn't, then you keep moving. If it has, then instead of saying this here where it's going up equals to true, I'm going to do a little pop-up, which we learned in the previous chapter. And of course it adds a bit of extra stuff, sorry about that. Okay, and we're going to want to make sure that it exits the game. Now if it doesn't exit the game, the ball is still going down, so it's going to be going down, game over, down, game over, and so forth. So it's a never-ending cycle. So I'll go ahead and exit that. See how that looks. Game over, closed. So as you can see, the program that was up here, that's what we have, other than the colors being green. Right, so this should help you. Here, though, when you're trying to go with the bricks at the top, make sure that you go through the entire array of bricks. You're going to check your ball to each and every single element. Therefore, you don't necessarily have to make a different rectangle for each one. Okay? So you can make it in the loop to where it equals the next one, it equals the next one, and so forth, to check every single one of them. That should be about it. I would highly recommend that some of these start being clearer instead of being weird numbers like this. So the window height divided by the size of, I don't know what you want to call the variable. Then this one would be number of bricks. Okay, minus gap. I don't know. So if you give them names, you could reuse them in other places. I know this one here, I would name the paddle width and the paddle height. And you will be using it some other places. So I believe that should be enough for you guys to play around with either the bouncing ball game, sorry, not the bouncing ball, but the brick breaker game. And if you don't like this, you can always go into the other Flappy Birds. Here's the Flappy Bird program. Okay, I'm obviously very bad. Run a file. No. I wonder how many takes it'll take me for... Ooh, there's one. Okay, so this game is just... It's probably simpler than the other ones. Okay, but it does have our image. These pipes are image, and the intercepts, whether this image intercepts this one. If it does, there's our game over. And this image is being controlled by a click, so if I click it, it moves up. If not, it naturally starts moving down, so you have to keep clicking it to start moving higher and so forth. The pipes and the background are moving to the left. Sorry. Okay, the score is 4. Go ahead and open that game. So it shows you how to get images. Since you have this program, you know where they're located. It uses a lot of little math. Now these right here, these pipes are always the same. There's no random element to them. So I wouldn't really like seeing pipes like this in a game. Here's every single time you click, it starts going in the upward direction. Here's all the pipes. The top and the bottom, the first one, top and the bottom second, top and the bottom third. This is not really that efficient of coding, but hey, we did it in like under an hour for this whole game. Whether they intercept or not. All these pictures are moving to the left. So remember, 0's on the left. So as the picture's got a specific X, it starts moving the X further left. If it reaches to a certain point, then it'll increase the score. And it does similar things up here. So if the location of the first picture, so it starts off, let's say right here, and it reaches a certain location, let's say over here, so it equals to -500, the location gets set back. Now, I actually have 3 different pictures for the pipes, so 3 different locations for the pipes, as well as the background. So the background is not one single image, it's 3 of them. And as it goes to the far left, it erases it while it's off screen and moves it to the far right while it's off screen, and then you get to see it again. So you're just seeing the same 3 pictures over and over and over. So yes, this is another example of a type of game you could do. I would really like for it to be challenging, you know, nothing to where it's only 170 lines. You know, something that people would like to play. At the end of chapter 13, there is a section that has sound, so maybe if you have some sound in your program. If there's any questions, email me. I will be in my office hours during the finals week, so I do expect a lot of people to show up. And that'll be it. Thank you.